Thank you. Thank you. Really, first off, I just want to say this is quite an experience. I've popped in and out throughout the day. It's been pretty impressive just to see how technology is evolving. These platforms and collaborative spaces are pretty interesting. And a lot of VRAR companies are starting to dig into that. But today I've got a bit of a presentation about some of the technology that Cirrus Labs has deployed using VR. Our company is primarily focused around uh, industry training. We focus on operator training and safety training in industry, so construction space, oil and gas, mining, and that sort of thing. Our core competency is geared around building simulators, and those are simulators using game engines. We started out quite some time ago. In 2005, we started out, there was only 3 people. We uh, we were using the Epic Unreal engine to build simulators for simulation for construction. So building simulators for Caterpillar and various things like that. We were a very small team, um, uh, primarily me and 2 developers. That doesn't include the ownership group. In 2006, we increased our size. Simulation was starting to take off. We had moved from construction using simulation into oil and gas, primarily building trade show pieces. So we would build simulators for drilling rigs, well servicing, and that sort of thing. Really about building awareness around how to operate the equipment. They were using more and more like sales tools rather than actually training. Um, in 2014, we started to really kind of dig into VR. A lot of the simulators that we were building were not unlike any other simulators. They were either built with projectors in a cave, or they were built with large screen televisions. Um, all worked fine for the time. You could put multiple screens wherever you liked, simulating, windows in vehicles or in pieces of equipment, and that satisfied a lot of the need at the time. But in 2014, we decided to explore VR because some of the simulators that we were building required kind of a spatial awareness, real-time risk assessment, looking around from below you, above you, beside you, and it would be hard to achieve that without some sort of a camera tool that would allow you to move the camera in the game to get a visual of the various risks you'd be encountering during the simulation. One of the products that we stared at the time and kind of prototyped some of the work was our aerial lift simulator. So you probably see these pieces of equipment on construction sites. They're generally a boom lift, which would basically be a chassis with wheels, uh, any sort of configuration of arms that would be, that would get you up to height. There would be a basket on the end that you would stand in. You would get you to height to do your work. So there's boom lifts, and we built one of those simulators, screen-based, that you could run with a piece of hardware as a controller, but looking at a screen. And it was almost the worst case scenario because you're really just a human being in a basket, and you have to get up to some height where there's usually structures, or there could potentially be pinch points or power lines or whatever that you have to be aware of in order to get up to that space. Um, so it became more of an instructor's tool. Somebody would operate it, instruct somebody, not unlike what I'm doing here, and the class, the people being trained, would have a better concept of how that piece of equipment operated and the risks tied to it. Um, but as a self-paced learning process for that piece of equipment, it really didn't solve the problem. There was no way to actually assess anybody. So we started to dig into VR and apply it to some of our simulators, and um, it was certainly effective from our early prototyping. In 2017, we were 21 people strong. We had aligned ourselves with major construction companies. We're partnered with United Rentals. You probably know who they are, largest rental company in North America. And we're building out a bunch of safety training programs. Part of that would be this simulator, as well as a whole suite of other simulators that we're building. Today we are 50 people strong, and I attribute that primarily to awareness around VR. I think in the last year and a half, there's been a lot of folks like Serious Labs, and probably a ton of the people you've heard speak today, who have traveled the world with VR kits, probably in some sort of hardened case that they'd check, and have some interesting stories around security getting through airports. But they've gone around, just like I have, building awareness, educating the general populace of what VR is bringing to the table, as well as AR. There's definitely a lot of awareness around that, and the applications vary. We've been specifically focused on VR. And I've done travel pretty much all over the globe. I've traveled all over North America. There's some spots there, Fort McMurray, Northern Alberta. Been up there. I've been all over the U.S. many times over. I've met with large organizations like Halliburton, Chevron, all throughout the U.S. I've been into actually, there's other slides here. I've been into China, Saudi Arabia, and primarily the UK. The products featured in the slide above. So you see on the left there is the SPSP. It's a technical school in Dammam, Saudi Arabia. The second picture is actually some of the demonstrations that we were doing. The gentleman standing up there with the headset is actually doing sort of what we're doing here. It's a collaborative VR. From Dammam to Calgary, Alberta, he's meeting with our CEO, Ken McLean. We were just networked, and there were some things we had them complete. They could exchange ideas. It was almost exactly like what we're doing here, which is pretty neat. We were all kind of chasing down that collaborative VR space. Up on the stage there is one of the crane simulators that we've built. Crane simulators benefited from VR in a big way, and I'll describe that in a little bit. And then we were over in UK, where Fylde College, another Blackpool Fylde College, which is kind of northern UK, just off the Irish Sea. They were looking at adopting VR as well. They were actually developing VR there as well. That was a couple of years ago. And then on the right, we have actually a few products. I believe the gentleman there is actually operating our first generation boom lift. He's got a headset on, and he's just driving it around, kind of getting a sense of what VR brought to the table. In the forefront of that image, there's actually a panel that looks like it's got a bunch of handles on it. That's part of our oil and gas simulators. That one has been around for a long time, and VR has really changed the face of that one as well. And I'm going to describe a little bit of where we were when you have VR as an application for simulation. It changes the scope. It's really changed the discussion. Most of the time, you have simulators that are large, they're costly, they're highly technical. They've got server racks, they've got multiple televisions. They're providing, it's not real time. There's a lot of things that aren't that kind of get in the way. They're barriers of entry, and we're guilty of that. I mean, we've done a lot of that ourselves. So you've got like a Caterpillar simulator right here. This is a wheel loader simulator with just a single screen in front. Effective, but not really. It gives you kind of a single focus. This one here is our snubbing simulator with a vertical screen. You can see the gentleman is operating, but he's operating from third-person perspective. In oil and gas, that's extremely challenging because presence is a big part of safety, especially in the well servicing operation that they're doing, which is called snubbing. Right here, we've got a drilling rig simulator, and you'll see that there's two screens, one above the other. those represent the doghouse windows. So that's really the control cabin on a drilling rig. They're two 60-inch monitors, and they represent the windows. There were some neat kind of mathematical algorithms that you can see that the piece of steel that should look straight is actually bent on the screen to offset the angle from the operator's perspective. These are all kind of little challenges that VR has actually solved just by putting a headset on, as well as the sheer space of what these consume. This one here is actually one of our most complicated systems. Not to, the control panel and everything that was tied into that is impressive, but we actually had three screens and multiple controls. But I mean, you're literally smothering the operator in large screen televisions as the room begins to heat up. Um, However, the this one here is now this here. So you see this gentleman has a headset on. He's got that panel. He's able to operate that piece of equipment um, flawlessly. And I'll just describe a little bit about the oil and gas side of this and why VR has changed that product in particular. Uh, Part of snubbing is, if you can imagine, you have oil and gas in the well, and it's kind of like oil and gas 101 right now, but I'll try and do it quickly. You've got upward pressure. There's a product that's trying to come up through the ground at a certain force. What you end up having is well servicing, like snubbing puts production tubing down the well bore, and it's kind of like a straw in a it's kind of like a straw in a fizzy bottle. If you put your thumb over top of the straw, that straw wants to float. Well, putting production pipe down a well bore that has surface pressure with a lift force will actually push the pipe out. This operation pushes the pipe down using hydraulic force. And so when you have an upward force and a downward force, there's a potential to break the pipe because you're actually putting too much stress on the pipe. So there's certain practices. Trust me, I'm getting somewhere with this. There's certain practices where you have a certain amount of gap between the part that's grabbing it at the where's the grip? There it is. Something that's grabbing it down there and something that's grabbing it up here, um, pushing it together. The shorter that gap is in the pipe, the less likely you're going to break the pipe. The only way you can tell, and that's called unsupported stroke length, the only way you can actually tell a safe zone on that is if you actually can see it in terms of scale and presence. And that's what VR has brought to the table there. He actually looks up and down into the wellbore, and it becomes a pretty effective use. Um, the crane simulator, very interesting product because we have stereoscopic headsets. You get a good sense of perspective. When you're operating a crane, it's critical that you actually get your hook load exactly over top of the desired location. So some of the testing and certification that's required is that you would have to move some object through a path. Wait, hold on. There we go. And one more. Oh, no, there it is. Sorry, I'm fighting with the controls. There it is. You move it through a path, a Z format, and it's all coned out. And in order to pass as a certified operator on a crane, you have to do that without striking anything. And the only way you can do that is if you know where everything is in relation to the load. So perspective is critical, and VR has actually changed the game for crane simulators. And this is a product that we've built. It comes both in a desktop as well as a motion base, and I'll cover that in a little bit. This one here is actually our aerial work platform. So the boom lift I mentioned earlier. This is actually the simulator in its full size. This was just 2 weeks ago, a week and a half ago, in UK at a job site where they're actually using workers to assess their ability to operate the equipment. Um, the the critical piece here is that even though he's only 6 inches off the ground, VR has given him kind of that sense that he's 60 feet off the ground. So, the visceral feel that you're at height. There's objects around you. it all kind of brings back that fear. If you have a fear at height, you're going to feel it in the headset on this piece of equipment. Uh, this in particular one is different than a crane in the sense that you don't actually, make a career out of operating this piece of equipment. It's a pretty fancy ladder for all intents and purposes. You're either a welder or a painter or a tradesperson who has to get up to some height to do a job, and they use that piece of equipment on a job site to get up there. So they're not expert operators, and oftentimes their confidence in operating that equipment is not where it needs to be. So this simulator is actually allowing them to get used to operating the equipment and feeling more comfortable at height. Um, Here we go. Uh, However, VR did introduce some challenges. If all of you are fairly familiar with VR, dragging somebody through a space, you'll feel it more with a phone. Dragging somebody in a VR headset through space that they are not controlling, me walking back and forth, I feel fairly in control with everything that's going on. It feels fairly natural. In simulators, you have a piece of equipment that's taking you through an environment, and that introduces kind of motion sickness. So, in order to solve that problem, we had to figure out how to connect what you see with what you feel to eliminate that motion sickness. Um, and that became this motion base. So we ended up going through a lot of prototyping and to find just the right motion base. I mean, we built the motion base physically, but there's actuators in here put out by D-Box. You'll probably know D-Box from theaters. They run them in kind of full motion seats at the theaters, um, and we implemented that over a course of time. So you can see here's the first version with our VR headset component that we're, little control. Just iterate. We want to fail fast, so we just iterate like crazy. Um, and then we tried again with a little bit of the motion base. Ended up rolling this out for about a year and a half. We traveled around with that from trade show to trade show, kind of getting voice of customer, whether this sort of a product would actually make a difference in the industry. And it certainly was clear to us that it would. This is the end result here, and you'll see on the list there, there's a few components. There's the motion base. There's a touch calibration system. So we've automated the process of calibrating the headset. As you can imagine, if you have a 6-foot person versus a 5-foot person, you want to basically not end up like Cody. I don't know if he's in here, but he's stuck in the floor somewhere. You want to be able to calibrate
Yeah, I'm in the
where that
floor.
person's head is. Are you still in the floor?
Yeah, I've
Sorry.
rebooted. Well, not rebooted, but came back in twice, and I don't know why.
All right. Sorry to call you out, Cody, but it's kind of funny. And then, we've got a couple of, you can see right up here, we've got a couple of control panels. So, which is an interesting challenge unto itself. When you have a VR headset on, you can't see your hands. And so there's solutions on the market that we're looking at. We haven't integrated any. Gloves are typically fairly expensive. So we're kind of observing what options can happen. Currently, we don't implement anything. We've done a lot of work around mapping exactly where those controls are. So when you're in the space and you touch the controls, they feel exactly where they are. So if you liken it to driving a standard vehicle, you once you find the clutch the first time, chances are you're not going to look for the clutch again. You'll just know where it is because it becomes familiar. That's how we treat that. And for the most part, over the last month of testing in the field, everybody seems to be comfortable with that. Arguably, it actually works better because this isn't Twitch gaming. You should be very deliberate about using those controls. You should be paying attention to where they are and making a very conscious decision about which control you want to move and when. So, for no other reason than you can't see your hands, it kind of forces that behavior. Uh, so what's next? I mentioned earlier that, and I realize I'm kind of getting close to the time, but I mentioned earlier we ran around doing kind of awareness on VR and collaboration. We started developing what we were calling One Room, which is a platform for this very purpose. And I ran around for a year and a half trying to, build awareness around that. What we realized is that there are organizations building things like Rumii that are out on the market that that we just couldn't compete with. We're a small company doing a lot of things, and this was just one of them. So we decided to switch gears and do more bespoke VR experiences, still in a collaborative space, but for the purpose of training and assessment remotely. So we've identified some key customers that we're working with right now to prototype some of the stuff. This is a screenshot out of one of the environments that we've created, and it actually doesn't do it very good justice there. It actually looks pretty impressive when you're inside of it. Um, but it's a global company, and we're getting a lot of traction with them. I think the biggest challenge that everybody would face is how do large organizations actually integrate this sort of technology? Is fairly disruptive. How do they adopt it? What are the securities? Where does the data get stored? All that stuff. Those are all challenges that I think we all face, and we're all circling it a bit. Um, in terms of the simulator stuff, these are the next pieces of equipment that we're working on. There's a skid steer, a forklift, that's a counterbalance forklift, a rough terrain forklift, and a loader. Um, those will all be on motion bases, so same deal, motion based, but it'll have a seat, it'll have the controls, we'll do all the control integration. Most of our development, we focus around training outcomes, what exactly we want to get out of that. And then we've got a whole fleet of cranes. So we've got currently a rough terrain crane, a Tadano link belt rough terrain crane. I think they're 100-ton. We've got the carry deck and the boom truck. And then these are the next four cranes that we're working with. We're working with actually Liebherr on these two, which is the overhead crane and the tower crane. We've got a hauler crane and the RT400 also on the docket. So we've got a lot of projects in the works. Um, again, you saw that we were only 50 people. I was just informed today we're 47 people. 35 of them are actually the developers. So we've got velocity, but not a ton of velocity. And of course, as the awareness grows, demand is starting to kick in. So it's an exciting time, I'm sure, for everybody in VR and AR. It certainly is for us. We're always looking for new opportunities, but that's kind of the end of it. I mean, I had so many different angles I could have jumped down, and to summarize it in 25 minutes is pretty difficult. So, thanks.